Hi everybody, in this video we are going to discuss about how we can remove a node in the beginning of a circular linked list. So if we are given a circular linked list like this, the input of the operation will be the list alone, and what is expected is this operation should return 10 because 10 is the data that is present in the first node, and this node must be completely removed from the linked list. So when I tell I want to remove it from the linked list, how I can do is I can declare a temporary pointer, right? I'll move the temporary pointer to the last node. So when I move temp to last node, my temp will be here, and then I will be making my temp's next part equal to the second node's address. Okay, because this node is no longer the first node, this is going to be removed. The second node will become the first node. So I should store the address of the second node in the next part of the temp, and then I have to give back this memory. Since we have got this memory using malloc, we have to use free to remove this memory also, and we should find a place, okay, or declare a variable where I can store this value. Before I free, I should have a variable, for example D. I will store it and I have to return. This is an algorithm that I will follow when I want to remove the first node in the circular linked list. Now consider the case, for example, if the list is empty, right? If the list is empty, then what should we do? It is not possible to delete an element in an empty list, isn't it? So you should communicate failure, but we have to return something. So let us return -1. And the next case that we have to consider is when the circular linked list having only one node. If there is only one node, then value will be here, and then next part will contain the address of itself. This is how a circular linked list will look like. And as per the algorithm we discussed, what we will do, we will declare a temporary pointer, make it to point to head, and next step of the algorithm tells you to move to the last node. But when you look at a circular linked list with only one node, that is the first node and that is the last node as well. So the temp will be here, right? And your algorithm tells you store data in D, right? I have stored it. And what it tells, you have to make the next part of the last node to contain address of the second node, right? So where I will go and find the address of the second node logically, it will be actually here is head, it will be the next part of the head, isn't it? So if I try to do that, again I will be here only, again I will be having the value here, right? So I should handle this case separately, right? This is a corner case, I have to handle separately, right? And we have to tell head equal to null, because if there is only one node and if that node is also going to be removed, then the list will become empty. So how do we represent empty list? You should make head equal to null. Now let us formally write the algorithm. Input is the list, and in step 1 you are checking if list is empty, you indicate failure. How we will indicate failure is, we will be using the global delete error flag and you will set it, right? And you have to return -1. And what you are doing here is, you are storing data. This is the temporary variable. In data you are storing the data part of head, and in step number 3 you are checking if there is only one node in the list. If there is only one node in the list, then you have to free the memory pointed by head and make head as null, and you have to return the data because already we have stored the data part. So you have to return the data, okay? Otherwise what we are going to do, we are going to make temp to point to head, and you have to move the temp to the last node, and now you make next part of temp is next part of the head. That is, we are storing the second node's address in the last node. That is what we are doing in this particular step, and you are telling now temp1 equal to head, right? Why? I need the address of the first node to free it. So I am storing it in temp1, and you are going to move head to the next node. You are moving to the second node, head to the second node, and free the piece of memory. Okay, so let us implement this and see now first, right? So let me take this in the header file. What we have already declared this error flag, delete error flag is there, and we have also declared the delete beginning function. And let us go to the C file. Here we are going to implement, right? So what does the algorithm tells for us? First of all, you are going to check if the list is empty, right? If is empty, okay, if is empty, then what should I do? I should do two things. First thing is, I have to set the delete error flag equal to 1, and I will return -1. Okay, I should return -1. This is what I will do. Always we should remember that whenever we are working with global variables, we have to be extra careful, and you have to reset in the function first of all. Okay, so I am telling delete error flag equal to 0, and then you are setting it. Then the next step of the algorithm tells you have to store the data. So let me finish the declarations. I need 2 pointers. One is temp, other one is temp1, right? And I need a integer data. Okay. So as per the algorithm, I should tell data equal to the first node's data part. How will I know? It is L head and then data, right? This I will make, and then I have to check if there is only one node. How can I check there is only one node, right? How can I check that? Is you have to check whether the next part of the head, okay, whether the next part of the head is equal to head. Okay, equal to head means it is inside L in C. Okay, so you have to tell if L head next is equal to L head, right? Then you can understand that there is only one value in the linked list, right? So in that case, what we have to do? You have to free head, right? You have to free head, and you have to make head equal to null. Okay, because the condition for null, empty list is head is equal to null, and you have to return data. These are the steps that we have to follow, and otherwise you are going to move next. And what you are doing here, you are making temp equal to the first node's address. Where it is in the head. Temp equal to head, and then I have to move temp to the last node, while temp not equal to, while temp next not equal to L head, right? When I loop like this, I will be moving to the last node, right? Move to the last node. So let me tell temp equal to temp next. Okay, and then what we have to do now, after reaching the last node, I have to make the next part of temp to be equal to the next part of head, right? So this is outside the loop. Here I have to make next part of temp equal to next part of head. Okay, that is, I am storing the address of the second node in the last node, because the first node is going to go out, right? And then I have to tell temp1, okay, this is for freeing it. Yes, let us do that. Temp1 is equal to head, right? And then we have to tell move head to the next node, right? You have to tell head equal to head next, head equal to head next, and then free the piece of memory with the address, right? So free temp1. Okay, after this we have to return the data. Okay, fine. So we have to check this code, right? The algorithm is implemented. So in the application file, we have called delete beginning, right? Let me tell t is equal to delete beginning, and after the function call, we have to check the delete error flag, right? If delete error flag is set, right? If that is true, then we can understand that some error has occurred. In that case, we have to print deletion failed, right? I have to print deletion failed. Otherwise, I will tell value deleted is, you can tell %d and comma t. Okay, so now we have made the function call also. Let us try to compile and check it. So to compile, we will use the shell script what we wrote earlier. So let me run it. You see these errors occur in cll.c. First we will try to clear those errors and come. It's very trivial. Is empty, I have not passed the list. Let me go to cll.c and look at the code in 107. I haven't passed the list, right? Actually the address of the list is coming to this function. So to pass the list, I have to put a star. And then free head in line number 115, I have given free head, but head is not known. Head is inside L, right? So L head, right? And then in 122 also, I have given head next. No, it should be L head next, right? And obviously this should also be L head, right? Here also it should be L head equal to L head next, right? Okay, I hope the errors or in this particular file should go off, but still I have got in line number 115 error. 115, let me go and check. Yes, this is actually I have to pass it as an argument, and then 116 L head, right? We have to give this. Now let us compile and check. Yes, it's gone. Now let us run the code. So what we are seeing here, let us write down and see what should happen. Let me check the application file. Here in the application file, what we are doing is we are using insert beginning and we are inserting 1, isn't it? So insert beginning is used and 1 is inserted, and insert beginning is used and 2 is inserted, and insert end 5 is inserted, and then insert beginning 3, okay, and insert end 4, okay, and we have got insert position 3 10. Okay, so the third position should be 10, and then we should have 1. This is how the list should look, and after that we are calling delete beginning. So 3 should go off and we should have 2 10 1 5 4. Let us see 2 10 1 5 4. Yeah, this is working for this particular case, right? So value deleted is 3. Fine, you can see that also here it's working fine for this case. Let me check for empty list. Obviously it should work, right? So let me comment all these lines and try it out. Okay, yes, compile and check. Yeah, it is telling deletion failed, but your list is in list print we are getting segmentation fault. Yeah, I know the problem. Actually I made a separate video also on that. I actually forgot to handle empty list in this circular linked list. So what we should do is if the list is empty, we have to check first of all. Okay, in single normal linear linked list there is no problem, but in circular linked list we have to explicitly check if the list is empty. If the list is empty, then we have to immediately return. Otherwise when we try to derefer the head, we will be in trouble. That is what is happening now. Okay, so let us compile. Okay, I think yeah, for this one we will just pass the list only, not the address. So we have to just pass L. Okay, fine. Yes, now if you execute, you can see that deletion failed and list is printed. And the one another case that we have to check is when there is only one value, right? When there is only one value, let us check this insert beginning. I have given only one value, 1, and then I am immediately calling the deletion. Okay, yes, value deleted is 1 and list printed. You see that there is no element is getting printed, so the list has become empty list. Okay, so I will be sharing the code in the GitHub. You can check it. Thank you.